Okay, can you hear me, Robert?
Yep, we're good to go.
Okay, very good. Um, 66 years ago, a 5 megabyte hard drive weighed a ton. And you can see the IBM hard drive being loaded on a 707 aircraft. Um, Fast forward to the year 2022, and we can put 1.5 terabytes of data on a micro SD card that weighs a half a gram. That is 600 billion times more data density in 66 years. Can our transportation and mobility be improved like this? Dr. Fry, a world-renowned futurist, says transportation shows that transportation's exponential. You can pause the presentation anytime you want for if you want to look through the slides. And if you have any questions, note the slide number and we can talk about those in the period after the presentation. Dr. Fry points out that the automation of transportation will have a lot of impacts, especially for cities. Cities will lose over half of their current revenue streams. 40% of sales tax comes from automobile sales. Over 10% of retail disappears. No need for traffic cops, no need for traffic courts, no judges and lawyers or DAs for traffic violations. That accounts for up to 30% of a city's income. Parking at an airport is over half of the income at an airport. He points out that infrastructure projects represent a huge payday and that there are several global mega projects that have been identified. The biggest projects in history will likely be the connection of the Bering Strait between Alaska and Siberia, the Gibraltar Tunnel across the mouth of the Mediterranean, and connection from Korea to Japan. And of course, bridging the Darien Gap through the jungles of South America. He shows that tube transportation is the top global mega project that can accomplish all of those global bridge projects. He points out that we currently ship more goods through pipelines than all other forms of ground transportation. So why not people and freight too? Before we get started with this, I'll ask you all to consider that travel in an evacuated environment on spaceship Earth is the most proven form of transportation in the universe. The moon has been orbiting the Earth for at least millions of years, all recorded history, it's been observed. The Earth is orbiting the sun at 67,000 miles every hour of our lives. The average human travels many billions of miles through space in a typical lifetime. Why can't we bring those conditions down to Earth? There have been big advances in transportation. The domestication of animals allowed people to double the standard of living compared to walking. Steam power, again, doubled the standard of living. Cars and aircraft doubled the standard of living. We can come up with new transportation that continues that trend. If we use the best transportation that has already been proven by market force, we can realize that car-sized vehicles are already highly optimized by market force. And we can also realize that a car interchange is much more efficient, has much more capacity, and much greater speed and throughput than the old train switching philosophy. A pair of ET3 tubes at a speed of 400 miles an hour has the capacity of 40 lanes of freeway traffic. At 4,000 miles an hour, it's the equivalent of 400 lanes of freeway traffic, 200 lanes in each direction. If we build a ET3 bridge across the Bering Strait between Alaska and Siberia, 120 capsules a second could carry 5 times more cargo than all of the container ships traveling between China and the United States. If each one of those capsules were filled with those 1.5 terabyte micro SD cards that we looked at earlier, that's 120 million terabytes a second data transfer rate. Everybody in the world could afford a swap of data of their micro SD card on their smartphone and transport huge amounts of data and eliminate a lot of the bandwidth requirements only for accessing that data and sending the access codes. But most of the data that's currently going through the internet, especially with streamed videos, could already be on those micro SD cards with the profile of the person that is using them. So connectivity can even be greatly enhanced by transportation. What is the cost of achieving a sustainable transportation system? There's environmental costs. ET3 offers 50 times more passenger miles of transportation per kilowatt hour as compared to the most efficient electric cars or electric trains. It uses 1/10 as much land. It uses a lot less materials and labor to build, yet it has 10 times the capacity of our freeways and railroads. The economic sustainability. ET3 improves transportation value by more than tenfold. The proven way to attract private investment is value. Each job created to prop up a passenger train absorbs the entire tax payment from anywhere from 5 to 10 average Americans. That's not sustainable. Humans are the only species to nurse the old at the expense of the young. This shows how ET3 in the very center of the screen up at the top, you can see how much less infrastructure required compared to airport runways or freeway bridges, or starting from the opposite side, maglev trains or high-speed rail, or the 2 Hyperloop proposals next to ET3. We also believe that people prefer driving in a limousine that you see in the lower left-hand corner, a limousine experience compared to a bus experience. And there's a lot of other advantages of traveling in car-sized vehicles, such as the disease vectors that you see are not really mitigated by the masks, but maybe some people at least believe that they are. There's a lot of competition in transportation, and the billionaire Elon Musk has copied a lot of elements of Hyperloop or of ET3 with his Hyperloop proposal. This shows a comparison of Hyperloop. If you notice on the right side of the screen, you will see ET3. The 100 is the relative cost of the tube infrastructure, and the 200 is the relative cost of the tunnel big enough to accommodate the transportation system. So you see that the small sized Hyperloop right next to ET3 will cost 3.15 times as much if it's above ground. If it's in a tunnel, just the tunnel itself is double the cost of the ET3 tunnel. A larger Hyperloop system, big enough to drive cars into, would cost more than 10 times as much for the infrastructure and more than 8 times as much for the tunnel. And of course, high-speed rail, to build a tunnel big enough to accommodate a high-speed rail, is 19 times more than with ET3. You can see some comparisons here between ET3 and Hyperloop. These are some of the value metrics that indicate the optimization of ET3 compared to Hyperloop, which is more optimized to support the market for cars than to challenge the market for cars. And of course, ET3 can operate at much higher speeds, much greater efficiency, and much lower cost. Security and safety are important elements of transportation, and ET3 offers energy, food, and water security on a global basis, moving water and energy to and from locations of plenty and to and from locations where there's not enough. Moving wastewater from areas to deserts could allow the deserts to bloom and grow a lot more food, and also provide the mechanism and infrastructure for transporting that food picked ripe, and instead of picked weeks before it ripens, and much higher quality, much lower spoilage, and much lower cost of distribution and accessibility. ET3 can move energy such as oil and natural gas, or batteries filled with energy, or solar panels to expand the energy capacity in a sustainable way. Safety and security are big concerns with our existing transportation modes, and ET3 can virtually eliminate the major causes of transportation related fatalities. The first ET3 project has already been built. You can see here in the lower center of the screen some of the prototypes first built in China. These were built 4 years before Elon Musk ever uttered the word Hyperloop. We are promoting a privately funded private-public partnership project. The cost of a demonstration for ET3 will be approximately $30 million, plus the cost of the right-of-way. And that's where a public-private partnership comes in, where private industry can provide the financing and the construction, and the government could provide the right-of-way. There is also the possibility of private right-of-way, like utility right-of-ways and oil pipeline right-of-ways, or electric power line right-of-ways. We'll need 3 miles for a 400 mile per hour ET3 demonstration project. 1 mile of that will be used to accelerate the vehicle up to the 400 mile an hour design speed. The vehicle will coast for 1 mile, and then it takes a mile to slow back down. During the mile that the vehicle is coasting, it can choose between 2 alternative pathways. One that is a thrill ride for the vehicle, where the vehicle rolls 360-degree roll, and another where the vehicle just continues on a straight path. And that proves all aspects necessary to network ET3, like freeways are networked, like automated freeways, and at a much, much lower cost. If this were built along a major 6-lane or more interstate freeway, it could be extended in each direction to provide useful transportation between the cities, and used as an amusement ride, could pay for itself in a couple years of operation. The ET3 Global Alliance team is a global network of licensees who are dedicated to bringing ET3 to reality. There are now around 400 licensees in 26 countries. Notice towards the upper left-hand corner, you'll see Frank Davidson and Iselene Davidson. Frank Davidson is the one that built the English Channel Tunnel. And next to that, you see Jacques Fresco and Roxanne Meadows of the Venus Project. This is Dr. Borquin next to that. A lot of books have been written about the shift to ET3 over the years. You see some of the prototypes from the team in China, started clear back in 2003, again in 2005, and in 2008, the first prototypes were built in China. So even though a lot of people don't know about it, ET3 is far ahead of Hyperloop. ET3 forms 4 pillars of a genius city, a key element to your smart city initiative. And you'll see the contact information here at the bottom of the screen. That concludes the presentation. And if there's any questions, we can go back. There are many other visuals that we can put up and talk about, and also interactive global maps on Google Earth. Any questions?
Okay, Daryl, thank you very much for the time and for all this hard work. I mean, this is clearly a lot of years and dedication. So I'll do a round robin here. We don't have a lot of folks joining us tonight. So Brian, would you like to start us off? Do you have any questions, comments, thoughts you'd like to add?
Sorry, I was muted. I don't have any questions. I've been studying ET3 for many years. I've known Daryl since about, I don't know, 2011, something like that. And well in tune with the idea and support it 100%.
Well, thanks for the question, and thanks for joining us tonight. Current, do you have any questions, thoughts you'd like to ask Daryl?
No, first off, thank you for your time, Daryl. I was at another one of your presentations on this, and it's I think it's amazing technology. I'm curious if you have partnered with any AI type technology or companies to be able to demonstrate this technology in a really immersive way, or if you're working on that or considering that.
I think that would be great to use AI to create a simulation of ET3 and make it much easier for people to understand. And also that could also improve the value proposition of ET3 by likely further reducing cost and further improving manufacturing techniques that are already in volume serial production. ET3 leverages the top technologies that are available to produce the infrastructure in factories that already exist. So from one perspective, trillions of dollars have already been invested in ET3. The companies that have made that investment just aren't aware that there is potentially a huge new market for their production capacities that might dwarf their existing markets. And while the demand for AI to further improve ET3 is probably a very small percentage of AI, we do believe that it will dramatically improve ET3. And we have done a lot of computer simulations, and we do have a lot of automated, or not automated, but animated ET3 presentations that show how the system works. a lot of those you can find on YouTube, and that can be further enhanced in the future with AI. If you know of any AI companies that might like to showcase their artificial intelligence by making those types of improvements to ET3, please have them contact us. I don't know if that answers your question or not.
Yeah, thank you. And definitely I'll be keeping that in mind in terms of that type of partnership. Thank you.
Do you have any other questions, Current?
No, not at this time. Thank you.
Okay, well, I got tons of questions. So you had mentioned in one of the previous slides a roller coaster experience that was an option. Can you go into elaborate a little bit more about that?
Yes, the first demonstration project for ET3 will cost about $30 million and take about 3 miles of straight and flat existing right-of-way. It could be built right along a freeway or right along a train track or a power line. And if it is built in an area that has sufficient demand, like a major city close to an international airport, it could pay for itself in about 2 years of operation, operated as a thrill ride with high acceleration, like a top dragster. In fact, ET3 linear motors could be juiced up to greatly exceed the fastest quarter mile times that are in aircraft, and a person could have a thrill ride to very safely and securely experience the acceleration forces of a top fuel dragster, or maybe even twice as fast as a top fuel dragster. Going 0 to 400 miles an hour in about 3¼ seconds would equal the world record top speed in the quarter mile set by a rocket powered vehicle. And ET3 could easily exceed that. It could be used as a thrill ride where there's 2 alternative pathways where the vehicle does a 360-degree roll as it does the ride. So we believe that there's a fairly large number of people that would pay $100 to do a thrill ride, much like they will pay to $100 to jump out of an airplane for a few seconds of free fall.
Okay, yeah, I can certainly see the Saturday night skit being written about that one. So you had mentioned China and the demonstration projects. I love seeing the snow, the ones with the snow there and stuff. So, but in China, it looks like what we're seeing coming out of there is more high-speed rail on, as they say, wheel on wheel or steel on steel or whatever. So, why isn't this being developed more in China?
This is being developed in China, and it has not been publicized much here in the United States, but there are literally hundreds, if not thousands, of references in China. And most of our growth of licensees have been in China. If you think that the Chinese producing electric cars are resulting in the status quo ICE manufacturers, internal combustion engine manufacturers, scrambling for the ability to make electric cars, wait until China comes up with being the cheapest manufacturer of a new transportation system that offers 10 times the transportation effectiveness of cars and aircraft.
Okay. So you got a map of the pipeline you were talking about with Alaska readily available?
Say that again.
Do you have a map of the pipeline that you were talking about with Alaska, the T-bone across the top there that you were talking about before? Is that readily available?
Yes, I will share my screen here again, and
Because that was the other thing we talked about, was one of the ways to make this an economic win was to consider natural gas and oil and coal and other things that we could also transport through these lines in addition to people, cargo, and the ride experience.
okay, so let's. Are you seeing this?
I'm seeing your screen.
Okay.
Because right now I've talked to Gary Gilliam at the bridge in Pennsylvania, and they're open. They've got some land near where they're working at. They're open to you know, a pipeline run through Pennsylvania and a pit stop by their bridge. As we've talked about, you put together a great presentation for the project on Texas. So we're looking forward to things happening down there. But Alaska, despite all of its challenges, at some point it's an inevitability if we ever want to be you know, have this connected to a global pipeline. And I think that the American first elements of utilizing what we have could benefit everyone, especially if we can get a lot of this stuff manufactured in the US for the US portions, which I'm assuming is still possible.
Okay, can everybody
I'm with you.
see this? Okay.
Now, why haven't you written a book on this and gotten rich and famous like everybody else?
Huh. Yeah. This is kind of strange. It's not displaying the map.
Well, you're zooming, so it could be possibly using up a lot of bandwidth and may take a moment to load.
Might have to turn on a layer.
Yeah, there you go.
Okay, so we can see here that Alaska figures very prominently in the key ET3 route, and these are just a few initial thoughts on some routes in Alaska that avoid the mountains as much as possible and result in the greatest amount of accessibility to resources. There are literally trillions of dollars of mineral resources, mostly oil and gas, in the North Slope area, and ET3 would make it so those resources wouldn't have to be used for motor fuels, but instead the oil companies could add a huge amount of additional value to that. Instead of selling it for $70 or $80 a barrel to be burnt up in internal combustion engines mostly, why not add a lot more value to that by refining it and selling it for $300 or $400 a barrel, or $500 or $600 a barrel, and using it for lasting purposes to make high-tech composites to make the capsules, for instance, or make ultra efficient, super insulated homes like Brian Prop's company is in the business of, with super insulation. A lot of those oil resources can be used for lasting purposes that will last many decades, perhaps even centuries, and instead of being burnt in a few weeks or months after being pulled out of the ground.
So what do you think the major hurdles are from getting this going in Alaska?
Well, I think the major hurdles anywhere are, really just lack of awareness and lack of commitment to using the are making investments at the highest potential rate of return instead of protecting existing investments that have already been made. And even the investments that have already been made can be greatly enhanced with a change in view or a change in focus. Very similar to what you were showing at first, where making things based on the value that it adds for the most amount of people possible. I challenge anybody to come up with something that will have more of an impact on the standard of living of everybody in the world compared to building a global transportation system that has that provides more than 50 times more transportation per kilowatt hour than our best electric trains or electric cars do today. ET3 can enable a typical 20-hour work week for everybody in the world to enjoy a basic survival level, or to enjoy a standard of living that few of us can even imagine, with the ability to travel from anywhere here in the United States to visit the Taj Mahal in India, for instance, would cost about $50 and take no more than 3.5 hours to get to from just about anywhere, any major city in the United States.
Okay. So we've been talking about this in the context of the North Star Economic Development District, which we talked about last night with Mark, as an opportunity for us to drive investment, like you were talking about, private equity investment into capacity building in Alaska. Next week, we have two identical resolutions for $500 million to be able to move forward with building infrastructure. And I have another investor who is willing to put up $5 billion in order to upgrade our utility grids, which is part of this. So one of the things they're interested in is the intertide, this being able to watching your map there, being able to move energy across the state and stuff. So would a pipeline like this be able to help us move oil as well as electricity around the state?
Yes, absolutely. And in fact, far more safely than any natural gas or oil pipeline, because with ET3, the natural gas can be either compressed or liquefied in and put in special containers, or dewars inside of a capsule. If those barrels of oil inside the capsule or the liquefied natural gas leak out into a capsule, it can be quickly diverted into a safe location. The access portals will be no further than 15 minutes apart. And of course, if the oil leaks out, it is contained within the capsule safely. If it leaks out of the capsule also, which is a very, very low probability, it would be caught within the tube. And then only if all three of those would leak at the same place would any of it get into the environment. So much cleaner and greener. But instead of just moving oil and natural gas from the North Slope of Alaska, what ET3 would enable is the ability for the workers to live in Anchorage or other existing cities instead of being away from their families for weeks or even months at a time. ET3 would allow those workers to travel in the same tube infrastructure as the oil and gas does, to be with their families every evening.
So, okay, well, that obviously brings up just a ton more questions, and the biggest one everybody's going to ask are how do you handle security with this stuff? How do you handle not only terrorism and stuff like that, but there's a lot of earthquakes and other natural disasters. How have you calculated in all of those things into this?
Yeah. So which one of those do you want me to handle first? Shall we talk about natural disasters a little bit?
Sure, natural disasters are a good place to start. I think they're going to be the most prominent to deal with because you don't look like there's a lot of congestion in the tube.
Yeah.
So
Yeah, not long ago there was a major earthquake in Turkey, and one of the ET3 licensees is expert physicist from Japan, and Japan has about 10 times the earthquake frequency of the most earthquake prone areas in the United States, such as California and the Denali Fault in Alaska. And Dr. Kamada did some calculations showing that with off-the-shelf technologies and components, linear actuators that are already being used in industry, that the tubes inside the ET3 tunnels can be mounted to the tunnels with those actuators that are capable of moving many times faster than the Earth is capable of moving during a magnitude 8 earthquake.
okay.
So the tube can stay in alignment while the Earth shakes around it.
Okay, so just good shock absorbers like they have on cars.
Essentially, and with some added techniques to that were developed actually in Alaska for the Alaska pipeline that moves oil from the North Slope to Prudhoe Bay, and where it crosses the Denali Fault, they built a the supports with I-beams laying on the ground, and they put Teflon sliders on the tube so that when the fault shifted, they expected it to shift up to 15 feet. And I think when the Denali quake happened, which was a magnitude 7 point something, or maybe even up to 8, the Earth moved, I think, about 2 meters, about 12 feet. And it allowed the pipeline to flex while oil was being pumped through it without spilling a drop of oil.
Okay. So terrorism, how we deal with the national security issues this is going to bring up?
Well, if we look at the earthquakes that cause a lot of fear among people because we don't know when or where they're going to happen, and we add into that all of the terrorist activities that take place with transportation, such as carjackings in parking lots. Those are the most common acts of terrorism. We have nutcases here in Colorado about 10 years ago that was taking pop shots at people while they're traveling down the road on the freeway with a high-powered rifle, and was never caught. There are, if we add up, like crashing into the Twin Towers with the aircraft, if we add up all those acts of terrorism and all those acts of God with tornadoes and hurricanes and flash floods, all of those do result in transportation related fatalities. But with all of them added up, that constitutes less than 1% of transportation related fatalities. With ET3, transportation will be much safer than it is with our existing modes, and terrorists will have a much more difficult time disrupting it than they do trains or aircraft or automobiles, and much less ease of targeting specific individuals in specific cars, because you can't see what's happening inside the tube and you can't precisely target a specific vehicle. So with ET3, even though ET3 is much safer, for terrorism and acts of God, we prefer to focus on what's killing 99% of the people in transportation related fatalities, which is primarily failure to control the vehicle. If we run off the road, there's a good chance that there will be a fatal crash. Or if stuff is allowed to get in front of the vehicle, like a deer or moose jumping out in front of the vehicle, a lot of people die from that every year, hundreds per year, and other transportation fatalities that are blamed on weather. I think about 20% of aircraft accidents are blamed on weather, and about 60% of aircraft accidents are blamed on pilot error. ET3 eliminates both of those, or almost eliminates, not completely, but almost eliminates both of those. And the mechanical failures of aircraft that are horrifically complex account for about 10% of aircraft fatalities, and probably about the same amount of car fatalities, like flat tires or blowouts of tires, or bearings failing in the wheels. Things like that do result in transportation related fatalities. With ET3, there's no moving parts and it's very simple, and much, much higher control of the conditions of travel compared to travel in the chaotic environment of city streets and the air, where storms can cause very high forces on aircraft, that wind shear can literally knock the wings off of aircraft. Yet we fly, and flying is safer than driving, and yet we drive, and driving is safer than bicycles are safer than walking for the same amount of passenger miles. So ET3 will promise to be about 30 to 40 times safer, 1/30th to 1/40th of the risk of travel with existing modes.
Great, I appreciate that. So we've talked about the economics of moving this stuff forward, and when we were talking about people paying for this as a transportation mode, that's why we were looking at Texas and other more densely populated areas. But what we have up here, the opportunity would be to replace the aging TAPS, which is a Trans-Alaskan pipeline, which right now can only carry oil. So, excuse me. So the question I'm curious about is that if we were to get have government support, get the financing, have everything in place, and started at the beginning of 2024, how long do you think it would be before we could be taking our first ride? And then the next question that's related to that is, how much of this could be manufactured in the United States?
Well, literally any or all of it can be manufactured in the United States, and um, since the prototypes have already been built in China, um, and using highly proven processes that are in volume serial production all over the world for making over 95% of the components necessary to build ET3 are already in production. So um, if there is the will to do it and the money to do it, it can be done very, very quickly. Some tooling would have to be built and some testing done, of course. Um, we scheduled for the Florida High Speed Rail Authority project back in um, oh, um, about 20 years ago. Um, we were one of 20 proposers that qualified to submit a proposal. Our proposal was for $253 million, and that was of private investments that were already identified by the High Speed Rail Authority. But instead, they decided to go with a $2.6 billion high speed rail project along that same right of way. And it was contrary to what the voters passed. So over 70% of the voters voted against it and repealed the Florida High Speed Rail Authority Act. So if there is the will of the people, which obviously there is, because about 60% of Floridians voted for the efficient and effective high-speed ground transportation system to connect the 5 population centers of Florida. Um, but instead, the government, with free help from the rail industry, drafted a specification that was a giant leap backwards. Instead of using the latest and greatest technology, instead of making things better, they protected the status quo. Instead of making things better and more valuable for the citizens, they decided to line the pockets of people at Disney and the high speed rail promoters, and resulted in something that was not viable from a financial standpoint and would have taken years to be built. In California, um, several $billions were spent on high speed rail, and less than um, 20 miles of that have been built. It's terrible what's going on, and if more people can become aware that there are better ways to do things and expect more out of our government and vote for people that are promoting the um, the high technology methods that are already proven all over the world and putting them to use, we can have high speed ground transportation to connect the whole globe and provide more than 50 times more transportation per kilowatt hour than the most efficient electric cars or electric trains. People like Elon Musk don't want that to happen because it makes a market for Tesla automobiles much smaller.
Well, the truth is that like the whaling ships and the oil vendors of old, transition markets are constant. And aerospace, geotourism, um, well, colonization, asteroid mining, there are a lot of high tech, well, industries that are in place that these could transition into to achieve much more wealth than they're experiencing now, which is exactly what you're promoting here. You know, what you're talking about isn't about this or that, it's an and that's what we're working with. Everything we're doing with the North Star Economic Development District is to not talk, promote the environment over the economy or the economy over the environment, but see how we could all thrive when we look at those things together. So it is now 7 o'clock, and I appreciate your time tonight. I will ask our patient audience, Brian, do you have any last questions, comments, thoughts that you'd like to share on your way out the door?
No, not at this time. I appreciate you hosting Daryl, and we need to do everything we can to get these ideas out there and generate awareness.
Now, Brian, are you the plastic guy that Daryl was talking about earlier?
Yeah, we manufacture structural insulated panels for extremely energy efficient buildings.
Okay, we'll circle back around to that conversation here at another time then, but I'm curious about that. So, Current, do you have any last minute thoughts that you'd like to share heading out the door?
No, just thank you, Daryl, and thank you, Robert. Thank you. It's been really great to and informative. So thanks so much.
All right. Well, thank you everybody who's going to make the time to watch this, and please join us tomorrow night as we learn about how to make biodiesel by scrubbing CO2 out of the air with Chris Hunter. So thank you again for joining us, and have a beautiful evening and stay bold.